Good afternoon, ladies and gentlemen, and welcome to the Umalca Prize Award ceremony of the 5th Latin American Congress of Mathematicians. The Umalca Prize is awarded at each Latin American Congress of Mathematicians to young scientists who have excelled in mathematical research and whose permanent address is in one of the countries of Latin America. The board for this award ceremony consists of Carlos Di Prisco, Secretary and Acting President of the Unión Matemática de Latinoamérica y el Caribe, Renato Iturriaga, Chair of the Scientific Committee of the 5th Latin American Congress of Mathematicians, Úrsula Molter, Professor at the Universidad de Buenos Aires in Argentina, Alberto Verhovsky, Professor of the Mathematics Institute of the Universidad Nacional Autónoma de México, Marcos Jardim, Professor at the Universidad Estadual de Campinas in Brazil. Prior to the beginning of this ceremony, I would like to share with you the protocol that we will follow in this event. After the intervention of Carlos Di Prisco, welcoming all of you to this ceremony, the chair of the scientific committee, Renato Iturriaga, will tell us the criteria and the procedure that was followed in order to choose the awardees of the Umalca Prize. Afterwards, the professors that accompany us at the board will present the laudatios that they have prepared for the awardees. Each one of the awardees will be invited to the podium, and Carlos Di Prisco will hand out the award while the diploma is read to the audience. The awardees will stay at the podium, and we will finish the ceremony by congratulating them with a big round of applause. Let me give the floor to Carlos Di Prisco, Acting President of the Unión Matemática de Latinoamérica y el Caribe.
Buenas tardes.
Acércalo, Carlos.
Buenas tardes. Ahora, ¿se oye? Sí. Buenas tardes.
Acércalo, Carlos. Acércalo.
Es un gran placer darles la bienvenida a esta ceremonia de premiación. It's a big pleasure for me to welcome you all to this award ceremony. The Umalca Recognition Prize, as Bernardo has just explained, was established to reward young mathematicians of Latin America and the Caribbean who have developed extraordinary mathematical work in Latin American institutions. A brief description of how the prize has evolved. In its first form, it was called the Umalca Medal Lecture, and it was awarded in 2000 in the first Latin American Congress of Mathematicians in Rio de Janeiro to Marcelo Viana. For the second Latin American Congress of Mathematicians, held in Cancun in 2004, the prize took a different form. It was awarded to Enrique Pujals for his work in dynamical systems, and there were two honorific mentions given to Mario Eudave of Mexico and Claudio Landim from Brazil. In 2008, in the occasion of the third Latin American Congress of Mathematicians held in Chile, in Santiago, the prize was given to three mathematicians: Alejandro Mas from Chile, Carlos Gustavo Moreira from Brazil, and Federico Rodriguez Hertz from Uruguay, three of them working in dynamical systems. There were also two honorific mentions: Jorge Lauret from Argentina and Fernando Codá Márquez from Brazil. In the fourth Latin American Congress of Mathematicians in Córdoba, 2012, the prize was given to Fernando Codá Márquez for his work in differential geometry and, in particular, the solution of the Wilmore conjecture. At that point, the executive committee of Umalca decided to uniformize the prize And a set of rules for the prize was produced and approved in the Humalca Assembly held in 2013 in Guanajuato. Those rules were the ones that were used to choose the candidates or choose the winners of the prize in this opportunity. We are extremely satisfied with the results of this prize. It was a very difficult task that Renato Iturriaga will describe, but I will finish saying that mathematical activity, mathematical research in Latin America has very high standards, and the prize is a way to recognize this and to point out some singular points of high-quality research in our region. Thank you very much for your presence. I think the ceremony will be, it would set standards for the future prizes that will honor the previous ones, but in the new form will continue in the years to come. Thank you very much.
Let me now give the floor to Renato Iturriaga, Chair of the Scientific Committee of the 5th Latin American Congress of Mathematicians.
Thank you, Bernardo. Carlos already spoke about the evolution of the rules, or better to say, about the facts of Humalca prizes and how they are converging to an equilibrium. They are rather simple now. From now on, 1 to 4 prizes that celebrate the strong Latin American mathematicians. They must be working in Latin America, and this time they must be less than 45 years old, and from now on, less than 40. This was a transitory article of this same meeting, no? The same assembly. And finally, they must be nominated by a Latin American institution. Bernardo, I said thank you. Let me clarify why I thank you. This time is not about organizing this wonderful meeting, but it is essentially for giving me the opportunity of thanking all the people involved in this process. First of all, let me thank the 11 participants for accepting being nominated by their institution or some other institution sometimes. They were all excellent candidates and made our work very difficult. I wish we could deliver more prizes, but the rule was 4 as the limit. Second, let me thank the scientific committee who was in charge of selecting these winners. As I said, it was a very hard choice, but I think we kept a civilized discussion. I know that this is about the winners and not about the committee, but I cannot properly thank the committee without mentioning them all. Alejandro Adem is over there, Hugo Aymar, Joan Lucas Barbosa, Javier Caicedo, he's over there, Jorge Cosio, he's over there, Alicia Dickenstein, Carlos Di Prisco, Alejandro Joffre, he's not here, Vaughan Jones, Carlos Koenig, Roberto Macarian, Consuelo Martínez, Carlos Gustavo Moreira, over there, Víctor Pérez Abreu, and Paulo Pichone. Finally, let me thank you all for your presence and attention. Thank you.
Let me invite Professor Ursula Molter to deliver the first laudatio of the evening and to announce the first Humalca Prize award winner.
Good afternoon, everybody. And It is a very great pleasure for me to announce the first Umalka Prize Award winner. The title is longer than I can remember. So this is our first winner, which I'm presenting. So I was asked to speak about Pablo's work and to present him here. It is really a great pleasure for me to be able to do so. Pablo started his mathematical career pretty early when he was in high school and joined the Argentinian mathematical Olympic team. And in 1994, he won the first gold medal in an Ibero-American Olympiad, which was held in Fortaleza in Brazil. After that, he started his study at the University of Buenos Aires. I have to mention that in the middle, he moved from Buenos Aires to Quequén, and this was for him very hard because he liked to attend the Olympic trainings in Buenos Aires, but nevertheless, he succeeded. Quequén is a very little city in Argentina, and he returned to then study mathematics at the University of Buenos Aires in the Facultad de Ciencias Exactas. There is where I met him in about the year 2000. He wanted to obtain a very prestigious scholarship, so he was just taking an elective course at our department, and he chose the subject to be the subject of his scholarship, and of course he was awarded it. In 2001, he got his degree. And just to mention, this is something I find very characteristic of Pablo. He worked very hard and he was not satisfied with his results because what he obtained did not fit the definitions. And so he decided to create a new definition. And this, in fact, was then his first publication some years later because other people had to accept that this new definition was valid. Well, Pablo then got his PhD in the United States under the advice of Solombiac, and there I can tell a little story. When he applied to Washington University, he had to give the qualifying exams. And obviously, students arrive there and take some time to take these exams. Pablo did not. He decided he was going to arrive and take them immediately. So I think he traveled at the end of August, and in September, he went through all the qualifying exams, getting the best marks in all, except for English. And there is another rule at that university that you have to pass English. So you cannot be accepted at the program if you don't pass the English exam. So they had to make an exception because they didn't have any other student who had passed all the exams on his first attempt but English. So he had to learn English for some months and retake the exam. So this is how he started in Washington University. And well, then he worked from then on, I believe he worked in geometric measure theory. He started his first work with multifractals, the multifractal formalism, which is what I told you. He redefined a different one to fit his idea. And I think he is a very thorough mathematician. And so maybe it took a while until his real strength became evident. His first big result is in 2009, So in 2009, he solved a very big open problem, which was posed by Furstenberg in the 70s. And many people had been working on that, in particular Yuval Perez. And, well, Pablo already during his PhD studies was thinking about this problem. He was thinking and he could not finish it. But then when he worked together with Perez, he told Perez his ideas, and Perez realized that with that, it was enough to solve the problem. And essentially, what he was able to prove, this problem you can put in words, is the question was, if you have two sets, let's say, on the circle, which are invariant under two different affine transformations, then their structure has to be very different. What does it mean, very different? Well, that if you take the sum set, the dimension of the sum set is exactly the dimension of one plus the dimension of the other. This means is that the sum set is very big compared to other cases in which the sum set take the counter set 1/4, when you sum it with himself, it's still a counter set. And the sum of the dimensions, as everybody knows, is 1, so one could expect a nice set, but this is not the case, because the counter set 1/4 and the other counter set have the same affine invariance. So, well, with Yuval Perez, he solved the case of self-similar sets. And then he started a really very fruitful collaboration with Mike Hochman from Israel. And there they were able to prove the complete general case in 2012. So they succeeded in proving the conjecture of Furstenberg. But again, the idea is, or the merit of Pablo was to develop or to bring into the subject new ideas. And these new ideas helped him to solve another long-standing problem, which was a problem posed by Erdős in 1939, about if you take a Bernoulli convolution, whether the Bernoulli convolution will define a distribution that is absolutely continuous with respect to a Lebesgue measure. I don't want to go into mathematical details. So the best known result for years, well, Erdős found only very few examples where this was not true. So it was supposed to be very few numbers for which this was not true. And then it could be shown that only very few of these numbers, the progress was very slow. And then all of a sudden, together with Mike Hochman, they were able to prove that the Hausdorff dimension of those numbers for which it is not true is 0. So the set of positive answers is really huge. So I think already this has been enough about telling the mathematics behind Pablo's work. And let me just finish by saying that this is really a pleasure to work with him. We are all very happy that he returned to Argentina after his long time outside, and we are more happy to have him in our research group at the university. So I congratulate Pablo.
Let me invite the first award winner, Pablo Schmerkin, to join us here at the podium. Carlos Di Prisco will hand out the award. Meanwhile, I will read the diploma to the audience. Unión Matemática de Latinoamérica y el Caribe, diploma del Premio Reconocimiento Humalca 2016. El Comité Científico del Quinto Congreso Latinoamericano de Matemáticos otorga a Pablo Schmerkin el Premio Reconocimiento Humalca 2016 por sus contribuciones importantes a la teoría geométrica de la medida y a la teoría ergódica. Firmado por Servet Martínez, presidente de Humalca, Renato Iturriaga, coordinador del Comité Científico del Quinto Congreso Latinoamericano de Matemáticos, dado en Barranquilla, Colombia, julio de 2016. Let us give a big round of applause to Pablo Schmerkin. Let me now invite Professor Alberto Verhovsky to deliver the second Laudatio of the evening and to announce the second Humalca Prize award winner.
¿Cuál es para?
Listo. Mira, pantalla. No lo primas la que tú quieras.
Okay.
Ahí.
Well, it is for me a great pleasure and honor to introduce the second Humalca Prize, 2016, and the award goes to Andrés Navas. In these few lines, I will see the laudatio. This prize is given for his outstanding work on one-dimensional dynamical systems, which focus on the rich interplay between group theory, in particular ordered groups, probability, topology, geometry, and analysis, especially for his contribution on Kazhdan groups. He proved an extremely good theorem on finiteness of Kazhdan groups that are represented as diffeomorphisms of the circle. And for general regularity properties of groups acting on the circle, à la Poincaré de Joie. Also for groups acting on intervals and the real line. And of course, this is the holonomy of foliations, and therefore has very important applications to the codimension 1 foliations. So in these few lines, I'm referring to an outstanding work. Let me now go a little bit into his personal appreciation. So first of all, let me tell you something is not written there. I knew Andrés Navas long before he went to do his PhD. And to me, he always was a boy, a 15-year-old boy. He, as you can see from the picture, he's always a youthful and dynamic young man. So that's just my particular appreciation. So Andrés Navas was born in Santiago de Chile on January 9, 1976. After finishing his undergraduate studies at the Universidad de Chile in Santiago de Chile, by the way, he already won several gold medals, Ibero-American medals, several prizes. He was a brilliant student. And he did his master's degree at IMPA, and therefore it's natural he would work in dynamical systems from... Well, he was granted his PhD in mathematics from École Normale Supérieure de Lyon in France on December 2003, with a thesis written under the supervision of one of our common heroes, Thiégis, a great mathematician and friend. And then he had a postdoctoral position at the Institut des Hautes Études Scientifiques in France. By the way, that was paid by a grant from Hodge, very good one. He stayed 1 year there, from 2004 and 2005. And of course, with the long list of the several awards he has received, received many prizes from his country, from Chile, but also a very important international prize. He was the recipient of the 2013 prize of the Mathematical Council of the Americas during the first Mathematical Congress of the Americas in the city of Guanajuato. And I want to tell you that this is very important. This includes also, apart from Latin America, includes Canada and United States. Well, let me tell you a little bit of, in the spirit initiated by another common hero of many here, Henri Poincaré and Aïjoa, his main contributions have been on properties of groups acting on the circle, closed intervals, and the real line from many points of view. Algebraic, for instance, he analyzes nilpotent groups, solvable groups, which act on the line, or on intervals, or on the circle. And he studies from many viewpoints, like minimality, ergodicity, amenability, and ordering, and also regularity properties. Like we know theorems like Aïjoa says that if diffeomorphs have certain regularity, they are better than others. Yeah, Andrés Navas has written, I just put here the ones that are listed in math reviews. He has written much more. And most of them in first class, some of the best journals in the world, like Acta Matematica, Análisis of Probability, Invenciones Matemáticas, Annales Scientifiques de l'École Normale Supérieure, GAFA, Geometry and Topology, and many others. Already this list tells you the versatility of his work. He has also written a book, which is now a classic, which is called Groups of Circle Diffeomorphism, and was published by Chicago Lectures on Mathematics. By the way, there are translations of this book in Spanish. There's one in Ensaios Matemáticos from Brazil, and also from IMCA. And he has another book that I didn't put here, written in collaboration with Bertrand Derwan. Andrés Navas has visited and lectured in various countries in our region, including my institute in Mexico, Cuernavaca, and has collaborated with many mathematicians from this region. And therefore, let me say that apart from his quality, the quality of his research, he has had a great influence in the development of mathematics in Latin America. He's a youthful and generous person, an excellent lecturer, and it's for me a great honor to be his friend. And really is, I believe that is for mathematicians like Andrés Navas that these prizes that they want are granted now, they are invented and they are set exactly for people like Andrés Navas. So I'm very honored to be given the opportunity of saying these words, which could be, I could have made them 10 times longer, but laudatio is by definition a short statement. So
let me invite the second award winner, Andrés Navas, to join us here at the podium. Carlos Di Prisco will hand out the award. Meanwhile, I will read the diploma to the audience. Andrés. Unión Matemática de América Latina y el Caribe, diploma del Premio Reconocimiento Humalca 2016. El Comité Científico del Quinto Congreso Latinoamericano de Matemáticos otorga a Andrés Ignacio Navas Flores el Premio Reconocimiento Humalca 2016 por sus importantes contribuciones a la teoría de los sistemas dinámicos y a la teoría de grupos. Firmado por Servet Martínez, presidente de Humalca, Renato Iturriaga, coordinador del Comité Científico del Quinto Congreso Latinoamericano de Matemáticos, dado en Barranquilla, Colombia, julio de 2016. Let me now invite Professor Marcos Jardim to deliver the third laudatio of the evening and to announce the third Humalca Prize Award winner.
Good afternoon. I'm very glad to announce the third Humalca Prize winner, and this is Henrique Bursting. So Henrique graduated in mechanical engineering from the Federal University of Rio de Janeiro in 1995. And fortunately for all of us, he decided to shift from manufacturing hammers to proving theorems. Henrique completed a master's degree in mathematics in 1996, also at the Federal University of Rio de Janeiro. He then moved to Berkeley, where he studied under the supervision of Alan Weinstein, obtaining his PhD in 2001. Subsequently, Henrique held temporary positions at these two prestigious universities, the MSRI, also in Berkeley, and the University of Toronto, before moving back to Brazil in 2005. Henrique's research concentrates on the Poisson geometry and related topics. Among these, I would include deformation quantizations, generalized complex geometry, Dirac geometry, the theory of Lie groupoids, and mathematical physics. He has published more than 30 papers with 18 different co-authors, including articles in some of the most prestigious journals in mathematics, like the Journal of Differential Geometry, Communications in Mathematical Physics, Advances in Mathematics, and the Duke Mathematical Journal, to cite just a few. His relevant work, his relevant and original contributions to Poisson geometry has earned him the Andrea Lichnerovics Prize in 2008, awarded by the International Conference on Poisson Geometry in Mathematics and in Physics. Quoting the laudation from this prize, Henrique's work in Dirac geometry not only advanced the subject, but it also was a source of inspiration for many further developments. More importantly, upon his arrival at INPA in 2005, Henrique has opened a new area of research there. I think it's fair to say, actually, that before his return to Brazil, there is no symplectic geometry done in Brazil at all. In the past 10 years, a large and very productive research group on Poisson geometry and related topics has emerged around him. Nowadays, this group counts with many researchers in at least 5 institutions in 3 different states in Brazil, and it has been meeting every year for the past 4 years in a series of workshops, involving mainly young mathematicians and graduate students from Brazil and elsewhere in Latin America. So it's a very nice legacy that Henrique has been building in this past 10 years in Brazil. Henrique's outgoing, friendly, carioca personality has most certainly been an important factor in the creation of this new research network in Brazil. I have known Henrique for over 10 years now. And over this period, I came to admire him both as a mathematician and as a friend. It is therefore a great honor to deliver the 3rd Umaka Prize to Henrique Burstein. Thank you.
Let me invite the 3rd award winner, Enrique Burstein, to join us here at the podium. Carlos Di Prisco will hand out the award. Meanwhile, I will read the diploma to the audience. Unión Matemática de América Latina y el Caribe, diploma del Premio Reconocimiento Humalca 2016. El Comité Científico del V Congreso Latinoamericano de Matemáticos otorga a Enrique Burstein el Premio Reconocimiento Humalca 2016 por sus importantes contribuciones al desarrollo de la geometría de Poisson y sus extensiones. Firmado por Servet Martínez, presidente de Humalca, Renato Iturriaga, coordinador del Comité Científico del V Congreso Latinoamericano de Matemáticos, dado en Barranquilla, Colombia, julio de 2016. Let us now give a big round of applause to Enrique Burstein.
Okay, so just to make sure, these words are Victor Pérez Abreu, except the first one, it's also my pleasure to announce Professor Robert Morris as the last award. Indeed, it is an honor for me to read this laudatio for Morris, a world young leader in the field that lies in the intersection of probability, combinatorics, more specifically in the extremal and probabilistic combinatorics and the application of randomness in deterministic settings. All Morris' work is impressive, of particular high relevance. His recent results on independent sets in hypergraphs, which lead to several applications in combinatorics and additive number theory. Morris was born in 1981 and did his undergraduate studies at the Christ's College in Cambridge. He continued his graduate studies at the University of Memphis, where he received a PhD in mathematics, working on the direction of Bela Bolovas. The PhD work of Morris and the one shortly after were outstanding. He proved excellent results on hereditary properties of combinatorial structures, ordered graphs, posets, oriented graph partitions, tournament, as well as on highly connected monochromatic and multicolor subgraph. This research led to 5 papers, 3 co-authored with Joseph Balogh and Bela Bolovas, and 2 others with Henry Liu and Noah Prince. They appear in journals like European Journal of Combinatories, Discrete Mathematics, and Journal Graph Theory. After his PhD, Morris was a research fellow of the Murray Edwards College in Cambridge and a postdoc in Tel Aviv, Tokyo, and Brazil. He is currently an associate professor at IMPA in Brazil. Morris is a very distinguished, prolific young mathematician in Latin America with a talent to work on several difficult problems at the same time, and with the characteristic that involves developing approaches and tools which are applied by others in different settings. Over his just 10 years of academic career, Morris has made fundamental research contributions focusing in a number of very loosely related areas: graph theory, Ramsey's theory, sum-free sets, bootstrap percolation, probability theory, and mathematical biology. In particular, he has made similar contribution in his work of superconcentrators, and his work on bootstrap percolation, and his work on structures of graphs. More specifically, he and his collaborators introduced a new technique for proving superconcentrations that was recently applied to completely analyze the so-called triangle process in random graphs and Ramsey's theory. In the bootstrap percolation topic, he and collaborators solved a problem that was open for several decades and that come from statistical physics to determine the precise value, the threshold, of a critical infection probability in dimension greater than 2. This result was published in the Transactions of the American Mathematical Society in 2012, co-authored with Joseph Balogh and Bela Bolovas, and Ugo Duminili-Copin. The starting point of this seminal research was a 50-page paper on the critical probability in 3 dimensions, which was published in the Annals of Probability in 2009. Focusing in the field of structures of graphs, he developed, among other tools, the hypergraph containment method that shortly demonstrates its wide applicability in graph theory and additive number theory. He gave an approximate structural characterization of the family of all independent sets in uniform hypergraphs whose edge distribution satisfies certain natural conditions. This is one of his latest papers, published in the Journal of the American Mathematical Society in 2015, co-author with Joseph Palloch and Wojciech Samotich. This last work on independent sets in hypergraphs found immediately several applications in additive number theory and combinatorics, such as the solution of an old Herdus problem, the establishment of tight bonds for Ramsey number, and the sparse random analogs of several classic results like Seremedi's theorem and Turan's theorem. One of Maury's more recent work has been on other challenging problems in statistical physics, combinatorics and probability, to understand the typical behavior of cellular automata, which are interacting particle systems whose update rules are local and homogeneous. In a recent work, Rob Morris and co-authors developed for the first time a general theory for their study, which did not exist for more than 50 years that cellular automata were introduced by Neumann. In the 2015, Morris was awarded with the European Prize in Combinatorics. Today, he receives the Umalka Prize.
Let me invite the fourth award winner, Robert Morris, to join us here at the podium. Carlos Di Prisco will hand out the award. Meanwhile, I will read the diploma to the audience. Unión Matemática de Latinoamérica y el Caribe, diploma del Premio Reconocimiento Umalka 2016. El Comité Científico del Quinto Congreso Latinoamericano de Matemáticos otorga a Robert Morris el Premio Reconocimiento Umalka 2016 por sus importantes contribuciones a la teoría combinatoria probabilística y a la teoría extremal de grafos, firmado por Servet Martínez, presidente de Umalka, Renato Iturriaga, coordinador del Comité Científico del Quinto Congreso Latinoamericano de Matemáticos, dado en Barranquilla, Colombia, julio de 2016. Let us give a big round of applause to Robert Morris, winner of the Umalka Prize 2016. Let me finish this ceremony by asking the four award winners to stand side by side at the podium. Let us give a warm round of applause to the Umalka Prize winners, Pablo Schmerkin, Andrés Navas, Enrique Burstein, and Robert Morris.